Greetings everyone. Today we're going to explore all the properties of exponents in a set of examples. You'll want your foldable for this, but if you don't have it, just pause when you need to jot down the question. Let's take a look at this example. Again, we're combining all the rules and properties we've learned so far. If you need to review those rules, you'll want to see the previous videos. The first thing I want to acknowledge on this one, that the parentheses mean that I'm multiplying. So technically, I could rearrange and draw dots to clarify the meaning of those parentheses. Everything is its own factor, so everything is being multiplied. If I rearrange, it just helps organize the thoughts in my brain. It helps me remember that when we multiply like bases, we add the exponents. And when we multiply like bases, we add the exponents. So don't let those parentheses throw you off. Rewrite it another way if needed. Similar on this problem, I'm going to start by rearranging and just writing dots. Do you have to do this step? No, but it can be very helpful for staying organized. It allows me to see that the only thing I'm going to do is multiply those like bases and therefore add the exponents. Let's review power to a power. We want to distribute that power to every base in the parenthesis. Technically, that 3 has an exponent of 1. When we distribute, we multiply. So that -3, 1 times 2. The x, 4 times 2. The y, 5 times 2. So don't forget about those integers out front. Next, let's simplify this. This said, hey, square the -3. -3 times -3 is +9. That's what that means. Now, it was originally in parentheses, so that's why we're including the negative. The x and y are positive integers, so we are done with that one. -2. Let's acknowledge that that 4 has an exponent of 1. That's 3 bases that I'm going to distribute to. 1 times -2, 4 times -2, 3 times -2. Next step, I have negative exponents, and that's not allowed. So if this is over 1, we want to move our negative exponent bases to the other side of the fraction bar. So that 4 gets kicked to the bottom. The x gets kicked to the bottom. The y gets kicked to the bottom. There's nothing left on top, so I'm going to write a 1. The last thing I need to do is, if I can take care of a number base, I should. 4 times 4 is 16. Everything else falls down. First thing I notice that I have a 0 power. Anything to the 0 power is 1. So I have a 1 to the 1. I have 3 pieces that I'm going to distribute onto. 1 times -2, -2. -3 times -2, 6. 4 times -2, -8. My next rule, anything with a negative exponent gets kicked to the bottom. Anything with a positive stays. Anything negative gets kicked. The last thing, 1 squared, 1 times 1 is still 1. So I actually don't need to write it. I can just leave my variables. If you write a 1 out front, totally fine. But we can leave it simplified like this. First thing I notice is x to the 0 is 1, and 4 times 1 is 4. So I'm going to rewrite this first just to show you what that would look like. Next, I'm going to choose to deal with my negative exponents. So it's helpful if I remember to put dots in. What that means is the 4 stays. The y gets kicked to the bottom. The 2 stays. The x gets kicked to the top, and the y gets kicked to the top. All I did was rearrange based on negative exponents. Next, let's simplify like pieces. 4 divided by 2 is 2. Y cubed divided by itself. Anything divided by itself is 1. And the x to the 6th doesn't have any other x's, so it stays. I see that I have z to the 0, which is 1. The next thing I'm going to do is move pieces as needed. The 7 stays. The x to the negative 3rd goes to the other side. The y stays. The z gets kicked to the top. And if I'm timesing by 1, my function will remain the same. I'm going to take care of this 0 first. That's 1. Anything to the 0 powers 1. Don't forget that. So now let's look at how many pieces I have. I have a negative 2, an A, a C, a 3, an A, a B, a C. Now remember, you have multiple pathways. I'm going to pretend to be 2 different students. I'm going to be student A in blue, and I'm going to be student B in green. I would suggest watching this first and then deciding which student you would agree with the most. The first option is to distribute that 2 to every piece. The negative 2. 1 times 2, 2. A, 2 times 2. C, 3 times 2. 3, 1 times 2. A, 3 times 2. B, negative 3 times 2. C, negative 4 times 2. Then student A says, well, I am going to move my negative bases. Stays. Oops, that's a C. Sorry about that. The C stays. The 3 stays. A stays. B goes to the top. And C goes to the top. Oops, I forgot my little square there. Next, we're going to take care of simplifying. I'm going to deal with the numbers. Negative 2 squared is 4. 3 squared is 9. I have 2 A's. Larger on the bottom. When you divide like bases, you subtract their exponents. There's 2 C's. When I multiply like bases, I add their exponents. I have a 14. And the B is by itself and stays by itself. Let's see what student B's approach would be. Another option is to deal with the inside first. Let's say they want to simplify their letters first. Negative 2/3 stays. We have 2 A's and the larger one's on the bottom, so that becomes a 1. We have a negative B, so I'm going to kick it to the top. We have 2 C's, C's larger on top. 3 subtract the negative 4 becomes a positive 7, double negatives. Then student B says, now I'm going to distribute. I only have 5 pieces to distribute to. The negative 2 gets a 2. The B, 3 times 2 is 6. The C, 7 times 2 is 14. The 3, 1 times 2, 2. The A, 1 times 2, 2. The last step is to simplify. Negative 2 times negative 2, positive 4. B stays, C stays, A stays, and 3 squared is 9. See how we got the same answer? So don't let a friend confuse you. If you are working with a friend, my suggestion would be solve on your own and check your answers in the end. The order in which we perform the rules does not matter. Let's take a look. I'm going to take care of y to the 0 is 1. I'm going to choose to distribute first. If you want to try something else, please do so. The 4, 1 times 2, 2. The x, negative 2 times 2, negative 4. The y, 2 times 3, 6. The x, 4 times 2, 8. I'm going to simplify for my last step. 4 squared is 16. The y is single, so it just stays. But I have 2 x's. The x is larger on bottom, so it's going to stay on bottom. And 8 subtract a negative 4 becomes a positive 12. Let's take a look. This was a common mistake on some of the assessments in the past and currently. I'm going to simplify that inside first. Let's talk about that. The m stays. Which n is larger? The denominator. Now be very careful. 3, the positive 3, subtract the top's negative 3, becomes addition. It's a positive 6. If they're the same, both positive, it's different, right? But these are different. 3 subtract negative 3. If that doesn't make sense to you, watch this. What if I kicked the n to the bottom? Then I'd have 3 and 3, which still would make 6. Okay? Let's take care of that distribution now, because now I only have to distribute twice. 3 times 2, 6. 6 times 2, 12. R to the 0 is 1. Let's take care of distributing first. That's my first choice. This has a 1. 1 times 2, 2. 3 times 2, 6. Negative 2 times 2, negative 4. For my last step, again, you could say, here's an option, stays, stays, gets kicked to the top. Okay? Think that through if that makes sense to you. I'm going to choose to combine my t's. The larger t's on top. 2 subtract negative 4 is 6. And r to the 6 stays as well. Notice if I was green. When multiplying like bases, we add the exponents. I would still have a 6. Okay, so that does make it confusing in the sense that you get to choose which rules sometimes to simplify. So stick to one that makes sense. Let me know what questions you have. This one I chose because of the integers out front. Okay, I'm going to choose, because there's a lot of like terms. Let's simplify the inside first. Let me show you what I mean. 5 over negative 15 is 1 over negative 3. Don't forget your basic rules for simplifying fractions. Next, the x's. X is larger on top. Remember, that's my shortcut. So someone might help you and teach you a little bit differently. That's totally fine. My shortcut is keep it where it's larger. 8 subtract the negative 3 becomes a positive 11. Y's. The y is larger on bottom. 8 subtract 4 is 4. Next, I'm going to distribute the negative 2. There are 4 pieces. Let me set it up here. The base of 1. 1 times negative 2, negative 2. The base of x, 11 times negative 2. The base of 3, negative 3 to the negative 2. The base of y, 4 times negative 2. Next step, let's move our negatives. The 1 gets kicked to the bottom. The x gets kicked to the bottom. The negative 3 gets kicked to the top. And the y gets kicked to the top. One last step. The y and x are where they need to be. They look good. They're positive. There's only one of each. Negative 3 squared is positive 9. Be very careful with that. 1 squared is 1, so I don't even need it. So be very careful, because here's what I see. Look at how that 5 over negative 15 became a positive 9, right? That changed a lot, so don't let that confuse you. Just do one little piece at a time. All right, again, this was an incorporation of all our rules. See the previous videos if you want to see those rules broken down, if you want to see them in simpler form. See the previous videos. As always, check Google Classroom to see what your task is to go along with this. Let me know what questions you have. Seek out help in the Sabre Center if needed. And until next time, have a good one.